Hello everyone, I hope you're having a wonderful day. Now starts day 3 of our breakout project. In the previous video, we got the ball not only moving, but bouncing off all of the walls, making for some pretty nice collisions. But now, we need something to actually hit. In this video, we're going to create our blocks, and we're going to do it with some new code. Normally, and you guys I'm sure have seen this before, accidentally, we'll somehow open up the designer. Okay, you've seen that before. And usually it means, oh darn, I hit something wrong, and there's a bunch of stuff in here. But what's actually happening here is the background code. This background code is what adds in our actual stuff. So we see, for example, we've got our paddle. Paddle.image is this image. Paddle location is this location. Paddle, I guess, tab stop, tab index, which is stuff that we don't usually use, but it's in there. It's by default. The name is even right there, so we can change the name. All of these things are what our design does. And we see right here is where it actually adds the control. It adds the ball or the paddle or the top wall or the side wall to our actual program. And we see here is where it actually creates the events. What I want to do now is through our code, not this designer code, through our code, I want to add a bunch of labels to make these blocks. And we're going to do that through the idea of loops. So buckle up. This is one of our cooler lessons, one that gives us a lot of freedom for the future. Okay, so what we need to do is we're going to want to do this whole block creation thing at the very beginning, which is why I had us create a form1 load thing. So below our form1 load, I'm going to create a couple custom functions. I actually do two. Maybe I just do one. I don't know, we'll see. All right, private void, and I'm going to have one called create blocks. All right. And then we're going to create blocks whenever we load the thing, which means it's going to happen right away when the program runs. Realistically, could I type this into here directly? Yes, but there is a super secret thing in the future that I want to do that it's going to make sense that create blocks is a separate function outside of load. Okay. Now, we're going to be creating 90 blocks. Do I want 90? I think I wanted 84. I don't know. We'll see. We might end up adjusting that number. In testing, originally I was going to do 9 rows of 10, but in testing I realized that it was better off to use rows of 7. And so I think I ended up doing 84, which is, 12 rows of 7? Anyway, we'll see what we end up with. Okay, so we need to create a place to put our blocks. And as promised, these are going to be for our blocks. We're going to do that in an array. So I'm going to create a variable, and these are going to be labels. Now, when you're creating an array, you type in the type it's going to be, and then some square brackets after that. What that tells the computer is that it is an array of labels. Okay, so we've specified the data type. Now we need to give it a name. I'm going to, of course, call this blocks. Whenever I create an array or a list, I always like to make it plural. That way I recognize that's a list. So blocks instead of just block. All right. And we're going to initialize this right now. So I'm going to say blocks equals a new, and it's going to suggest it, label. And then in the square bracket, we need to tell it how many we're going to put there. Like I said, in testing, I ended up with 84. We might adjust this number later. But this way, we're only going to make 84 of these. There are only, right now, there's 84 spots saved. This is the big difference between an array and a label. Arrays are saved in something called the stack, which makes them more very quick to access. But we have to specify exactly how much space we're going to be taking up before we actually do this, which means we can't actually make this array any longer without doing some pretty advanced stuff that's more advanced than this class. So right now I have an array that is a bunch of labels. The way I like to think of this is a big old bucket. This bucket can hold 84 labels total. If I change this to an 86, it'll give me a slightly bigger bucket. But we're going to do 84. All right. Now, let's fill that bucket. If I wanted to, I could do it like this. I could say blocks, and then in the bracket, so that tells it it's an array. Inside the bracket, we would tell it what number spot. In computer programming, we start by starting at 0. So block 0 is going to be our very first thing. So block 0 is equal to a new label. Okay? We just create a new label. Now let's specify some features of it. First, let's change its color. So let's say blocks, 0, and I'm actually going to type that a lot. So I'm going to copy paste this. So I'm going to type that a lot. All right, block 0 dot, well, it's a label, so we can change a lot of stuff about labels. When I click on the label, it will say things like text. We want the text to be empty for this, so I'm not going to bother with that. But I do want to change the back color. Let's make this a nice color. I'm going to say back color is the color chartreuse. Yeah. I think it's a green. We'll see. All right. Great. We got the back color. We don't need forecolor because there's no text in it. Remember, forecolor changes the text color. But we do need to set the size. So I'm going to say blocks.length. Is it length? No, it's width. Sorry. Width. Blocks.width is going to be equal to, let's make it 60. We might adjust that later. We can adjust these pretty easily. And then blocks.height, that's going to be a height of 20. So they're going to be 20 by 60, 3 times as wide as they are tall. What else do we want to change? Let's put this first one at blocks 0. We'll set the location. Oops, hold on. We'll set the location to, we'll have it start at 0, 0. All right. So we've got a width. We've got that. I do want to set up a border for this. So I'm going to say blocks 0 dot border style. And trust me, you're going to want a border. I like, for this project, through my testing, fixed 3D. I think that looks really good. All right. Now, just like in our designer, which I'll pull up again, so what we just did is this stuff, where we created the properties of it. This one, they're changing the image, the location, all that stuff. We did all the stuff that we wanted to do. But what we need to do now is actually add it to our project. So I'm actually going to steal this line of code. Eventually we'll just type this in, but I'm going to steal this line of code. And we're going to this, which means the form itself, dot controls, so that's the list of things in it, dot add, but instead of ball, we're going to do blocks 0. Oh, I'm so excited. We actually don't need this in there. Controls is just fine. This is kind of redundant, although I actually do like it in there. We'll just keep it in there. All right, so now if I create blocks, I am creating a block right there. Do you see it? Well, you probably don't. It's because it's hidden behind this pipe. 0, 0 is right there. So let's fix the location a little bit. Instead of it being at 0, 0, let's make it at 40, 40. All right, let's check this out now. Hit start. Why isn't that starting? Start. And we've got a block. And sure enough, chartreuse is that color that I thought it was. All right. Now we got to make another. And hopefully, you have realized that we've run into a problem. If I make another, I have to type all these lines again. And then if I make another, I have to do that again, and again, and again. 84 times. Well, that sounds awful. Luckily, in computer programming, we have a way to redo similar code over and over and over again. And it's with what's called a loop. There are two main types of loops, while and for. A for loop is usually for counting, while a while loop will usually run until something is true. Most of the time, oh, see, I swear it heard me. It already wanted to type that in. Usually, a while loop is that infinitely running loop that keeps a function running. But because we're counting up to 84, we're going to use a for loop since we're counting. All right, first I'll drag those in a second. So this is how you set up a for loop. First, you need to make a temporary variable. Usually, you make your temporary variable I, and then you put a semicolon. So this tells the computer, hey, make this tiny little thing called I. Then we tell it what I needs to count to. I'm going to say I is as long as, so this is how long it's true for. Do this as long as I is less than 84. And then we're going to do another semicolon and tell it what to do with I at the end. I'm going to say I plus plus, which means make I go up by 1. Why do we have an error? Unused local variable. I don't know what you're talking about. I'm literally using it right here. Whatever. I'm sure that'll go away as soon as I type this in. Okay, so now I'm going to put this code in here. But as it is, all this code is going to do is create block 0 over and over and over again. What I want this to do is create block 0 and then 1 and then 2. Oh my goodness, I remember what I need to do. I need to tell it what to start I as. I equals 0. There we go. So we want it to start at 0 and then go to 1 and then go to 2. And so instead of using I, well, why not use the thing it's counting? Or instead of using 0, why not use the thing it's counting with, which is I? So I'm going to get rid of all these zeros, and I'm going to use I instead. And I'll explain why in a second. You're going to see some other fancy stuff with I. All right, and then we're going to actually add I itself. Usually, if you're going to forget something, it's this I right here. Don't forget this I. So now, it should create 84 I's, or 84 blocks. Watch what'll happen. So the first one, it'll say I is 0, and it'll go into this code. It'll say block 0, instead of I, it's 0. 0 equals new label. The back color for block 0 is chartreuse. The width for block 0 is 60. The height for block 0 is 20, and blah, and blah, and blah, then add block 0. When it hits the end here, because it's in a for loop, it'll bounce back up to the top and then do this, which adds 1 to I. So now I was 0, now it's 1. So now it's doing block 1. Block 1, block 1, block 1, block 1, block 1, gets to the end, goes back up here, plus plus, goes up to 2. And it's going to keep doing that until I is not less than 84, which means as soon as I hits as soon as I hits 84, it is going to break out of this. Okay, so now let's run it. And ta-da! Do you see them? Do you see all 84 blocks? Well, that's because all 84 blocks are in the same location. They're at location 4040. So, the next code I'm going to use is a little bit of math. It's not really advanced math, but it does require a little bit of thinking. So I'm going to type it in, and I want you guys to just kind of copy it down. You may have to adjust it to fit your exact screen, but c'est la vie. All right, so instead of this just being 40 every time, I'm going to have it be 40 plus whatever I is times the width of my block, which I said is 60. So that means when I is 0, then this will be 40 plus 0, because I times 60 would be 0. So it'll be 40 plus 0, which is just 40. So it puts it in the same spot. But when I is 1, it'll say 40 plus 1 times 60. What's 1 times 60? But 60. So now it's 40 plus 60, which is 100. The next one will be at 140. The next one will be at 180. Let's see what that looks like. And now we see a ton of labels. And you can see why that border is kind of important. All right, let's see how many we actually fit in there. 1, 2, 3, 4, 5, 6, 7. Okay, 7 is the number we want. But you see, it actually goes past that. If I drag this out, we see all 84 of those labels. All right, so what we need to do now is have it go to a second row. So I'm going to say, and this is some fun math. Instead of just doing I I'm actually going to do, and we've actually talked about this a little bit before, I'm going to do I mod 7. Remember, modulus means divide by that number and take the leftovers. So 0 mod 7 is 0. 0 divided by 7 is 0 with no leftovers. 1 divided by 7 is 0 with 1 left over. So it'd give you 1 here. So doing this will count to 7 over and over and over and over again. And then what I can do is have it go down. So I'm going to say 40 plus the height of these times, we need to do factors of, not factors, multiples of 7. So what I'm actually going to do here is times, and then in parentheses, this is where this gets weird, 7, or I divided by 7. Because I is an integer, it's going to clamp it. So, for example, if I was 2, 2 divided by 7 is 0.1 something, 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 something. Maybe 0.2 something, something. Either way, because it's 0 point something, and I is supposed to be an integer, which is a whole number, it's going to cut everything else off. It's just going to stick with the 0. So if I is 0, 1, 2, 3, 4, 5, or 6, then this number is going to be a 0. Once I is 7, then it's going to be a 1. Once it's a 14, it's going to be a 2. So pause right here, type in this code. I'm going to add some spaces in here so it's a little more readable. And then I want you to test this out. Hold on. Let's get those extra spaces in there. All right. Fingers crossed. Whenever I type in something like that, I do get a little nervous. Run. And, oh, look at all those blocks. Beautiful, 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 beautiful. Okay, that looks great. I'm very happy with that. All right, I'm going to hit space, and okay, we start run into a problem. The ball is going right through the blocks. We're going to need to add in some collision. But we know it works, so if you need to, go ahead and pause the video and copy this down. All right, so we've got create blocks happening right at the beginning. Now we need to do some block collision. This actually, well, we've already got a timer for the paddle and then a paddle collision. And we've got a timer for the ball and the ball collision. I feel like we should actually check to see if the ball is hitting the blocks inside of ball collision. So let's go ahead and type our collision code in there. So we're going to do another for loop. And the reason why is we've got 84 of these guys, and we need to check to see if our ball hit the label individually. So, here we go. This is what we're going to do. I'm going to say for, actually, you know what? Let's steal the code. It's going to be the exact same code as this, because we're counting up to 84. Copy. All right, let's get rid of this for. Paste, and there. Okay, so I'm going to say, just like this code, where if ball.bounds.intersects with. So we're going to actually take that much. Let's grab that. Doing a lot of copy pasting, which I love. All right, if ball.bounds.intersects with, except instead of intersecting with the paddle, we want it to intersect with one of the balls, or sorry, one of the blocks. So I'm going to say blocks. Well, let's start with 0, and since I starts at 0, we'll do I. All right, so if we hit the block, for the most part, and this might run into some issues, because of the way the blocks are, for the most part, we're going to be hitting them from the bottom or the top, depending on if we bounce up above. If we are hitting them from the bottom, we want our ball to keep its horizontal trajectory, but flip its vertical. And that's probably about as good as we're going to get on this. We're actually not going to program in hitting from the side. So I'm just going to assume that I always hit the wall or hit the block from the bottom or the top. So if we hit a block, I'm going to say balder V gets flipped. Goes not balder V. Great. All right, that bounces it. Let's try that out. See if we actually bounce off the blocks. All right. I believe in us. Let's go. And we bounced off the blocks, just like as if it were the wall. Okay? Bounce, bounce. All right. So now we just need the blocks to actually go away. Uh-oh, I got behind a little bit. Okay, that was a bug we might need to fix. We came in from the side, and so we weren't actually able to jump out. All right, anyway, so that's something we're going to need to fix. We're going to need to get rid of the blocks after we hit them. But that is going to be code for another day, because I believe our video is officially 20 minutes long. Have a wonderful day programming.